For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@architectureassignmenthelp.com or reach us at https://www.architectureassignmenthelp.com. For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@architectureassignmenthelp.com or reach us at https://www.architectureassignmenthelp.com. 1. The attic of a single-family house has 8 inches of fiberglass insulation, K equals 0.028 BTU/HRFTF, on the attic floor. The homeowner has added 2 inches of foam insulation, K equals 0.015 BTU/EFTF, on the underside of the roof. The outside air temperature is 40 F and the temperature of the occupied space beneath the attic floor is 70 F. The outside environment and the indoor environment can be looked as black body, which has same temperature as the outside and inside air temperature respectively. The foam and fiberglass insulation also can be viewed as black body. Assume that the air in the attic is at a uniform temperature. A. If the attic is sealed so that no outside air can leak in, set up but do not solve the electrical analogy for the heat transfer from the interior of the home to the outside air through the attic. Estimate the numerical value of each resistance element in the electrical analogy in terms of the attic floor area, a floor. B. If the outside air flows into the attic at a flow rate of MO, set up, but do not solve, the equations that will allow prediction of the attic air temperature. Clearly identify the definition of all terms in your equations. Assume the air in the attic is well mixed at a uniform temperature. architectureassignmenthelp.com. 2. After he has conquered most of the architectural challenges throughout the world, it might be appropriate for the Stata Center architect to help NASA design the future space-based Stata Center. As usual, the design will be over the top, requiring substantial electrical power for many years of operation in space. It is proposed to use a reversible engine that receives heat from an isotope heat source. The isotope provides heat to the engine at 1000 K. T1 architectureassignmenthelp.com. On the low temperature side of the engine, heat is rejected by radiation heat transfer to outer space, effectively at 0 K, by use of a black flat panel radiator at temperature T2. Only one side of the panel acts as the radiator. Most of the power plant system weight is due to the radiator panel, whose weight varies linearly with its area A2. The engine must produce a continuous power of 1 megawatt. Note, in this problem the large temperature difference between T2 and outer space precludes the use of the linearized form of the radiation heat transfer. A. If T2 is set at 300 K, how large an area A2 is required for the system to generate 1 megawatt of power? B. Consider different possible values for T2. Sketch a graph showing how Q2, the heat rejected by radiator, varies with T2 for a fixed power output and fixed T1. Now sketch the ratio of A2/Q2 as it varies with T2. C. Indicate graphically how you would use the results of Part B to find the value of T2 that minimizes the radiator area A2 for a fixed power output and a fixed value of the upper temperature T1. architectureassignmenthelp.com. 3. In winter, a MIT conference room has 100 people gathered together for a meeting. The current indoor air temperature is TIN equals 28.0 C. RIN equals 90%. Because there are heat sources generated from people and equipment in the room, this conference room may become hotter and hotter if we don't supply cooling air into it. architectureassignmenthelp.com. A. some people suggest supplying outside air directly into the space via diffusers without any heating or moisture addition. The current outside air temperature is 0 C, RH equals 80%. Is this strategy feasible? If yes, please give its advantages. What are its drawbacks, and how would you improve it? B. The indoor air temperature becomes tin equals 25 C, RIN equals 60% after 1 hour. In order to keep this condition steady, we need to supply a constant flow rate of air into this conference room. If the heat generated by each person is 80 W, the vapor generated by each person is 180 G/HR, the heat generated by equipments is 5000 W, the heat loss through the room's facade is 2000 W. How much air should be supplied into the room if we keep the supply air temperature as Ts equals 18 C? What should the relative humidity of the supply air be to maintain the room RIN at 60%? Assume that the exhaust air has same state as indoor air, tin equals 25 C, RIN equals 60%. Assume that there isn't any air leakage or other heat transfer into the room. Specific heat of air, Cp equals 1.01 kJ/kg.OC, is constant between temperature 0 C to 30 C. Architecture assignment help.com. For in a large air conditioner, the refrigerant in the condenser transfers heat to cooling water, see the picture. The cooling water flows to a cooling tower where it is sprayed as very small water drops into the top of the cooling tower. Ambient air will be induced into the cooling tower from the bottom by a fan installed on the top of the cooling tower. There will be some water evaporation from the droplets, and there will also be heat transfer between the air and water in the cooling tower. Then the cooled water will be returned to the air conditioner's condenser. We assume. Architecture assignment help.com. A. The water pipe between the condenser and cooling tower is insulated so that there isn't any heat exchange with the outside environment. B. The cooling tower facade is insulated very well and there isn't any heat exchange with outside environment. C. The condenser is insulated so well that there isn't any heat exchange between the condenser and ambient environment. That is to say, the refrigerant only exchanges heat with water in the condenser. We know. A. The water temperature before entering the cooling tower is Tw1 equals 35 C, and the water flow rate is 60 kilograms per second. Specific heat of water Cv equals 4.18 kJ/kg.OC. B. The air temperature before entering the cooling tower is Ta1 equals 25 C, RH equals 60%, and its leaving temperature Ta2 equals 28 C, RH equals 100%. The flow rate of the air is 25 kilograms per second. C. The COP of the air conditioner is 3.0. Questions. What is the rate of water evaporation in the cooling tower, kg/s? B. Calculate the value of the temperature, Tw2, of the water returning from the cooling tower before it enters the condenser. Architecture assignment help.com. C. If the air conditioner is used in steady state to cool a room space, what is the rate of cooling, QC? Architecture assignment help.com. Problem 1. We name the heat transfer coefficients as the following figure labels. A. The electrical analogy for the heat transfer from the interior of the home to the outside air through the attic can be drawn as Architecture assignment help.com. Estimation of the numerical values of the resistance elements is shown in Table 1. From Table 1, we see that the dominant resistance of the heat transfer through the attic lies at the two conduction resistances of foam board and fiberglass insulation. This finding may help us to understand question B's solution. Table 1. Estimation of the resistance elements, Unit 1/BTU/HRFT2.F, a floor. Architecture